So E appears in a lot of limits. Okay, that's why we're seeing it here, and a lot of limits in that have this form or forms like this. Okay, and we're going to see them some examples because it's very useful for your exercises and exams. Okay, so let's start with a simple one. The limit when n goes to infinity of 1 plus 1 over n of 2 to the n plus 1. Okay, this is just the same as the limit when n goes to infinity of 1 plus 1 over n times 1 plus 1 over n to the n, right? So this is the brackets. Now these two sequences are convergent, so this is just the limit of the first times the limit of the second, right? Now the limit of 1 plus 1 over n is just 1, and this limit is e, so this is e. Okay, just like before. Okay, now let's see a similar one. One plus 1 over n squared plus 1 over to the n squared plus 1. Okay, well, this is a subsequence of well, the sequence 1 over n squared plus 1 is a subsequence of 1 over n, right? And indeed this is a subsequence of this general term 1 plus 1 over n to the n, right? Because instead of taking every number, you're just taking the square plus 1. Okay, so you have the sequence is this, whatever, and then you're having n squared plus 1 is 2, 5, 10, 17, whatever, right? So these are clearly numbers in this sequence, but not all of them. Okay, so this is a subsequence, and we know that subsequences of a convergent sequence have the same limit, so the limit here is going to be the same as the original sequence, which is this. So the limit of this is e. Okay, and so this is a general rule. Okay, whenever you're having something like this, 1 plus 1 over, and then some function, let's call this b sub n, and then this is b sub n, the same thing, and b sub n is a subsequence that is monotonically increasing and divergent to infinity, then this is going to be a subsequence of n, right? So the limit of this is going to be e, okay, as long as this is true. Okay, now the limit when n goes to infinity of 1 plus 1 over 3n squared plus 1 over 2 to the n squared minus 3. Okay? Okay, now, so we can, let's see how to rewrite this. We can rewrite this as, so this is the limit when n goes to infinity of 1 plus 1 over 3n squared plus 1 to the 3n squared plus 1, right? That we know this is going to go to e, and but in order to have the same result, this is going to have 3n squared plus 1, right? Because we're just multiplying and dividing by 3n squared plus 1 in the exponent, so we can do this. Okay, now we know that the limit of some sequence to the power of another sequence is just the limit of the basis, so 1 plus 1 over 3n squared plus 1 to the 3n squared plus 1 times the limit of the exponent. Right? Now this thing is going to be e, and the limit of this, if you remember from last video, is going to be 2/3. Okay, we can take common factor n squared here, cancel each other out, and these two guys would go to 0. So this limit is going to be e to the 2/3. Okay, And so you can generalize this idea that we have used in here for sequences of this form. You have, let's say, 1 plus b sub n to the c sub n, where b sub n is going to 0 and c sub n is going to plus infinity. Okay? Well, the limit of this is going to be e to the limit when n goes to infinity of c sub n, b sub n, right? Okay, so remember this. This is the same as we have said before with the example. And in general, you will see many times you have the limit of some, well, let's write it like this, some sequence a sub n to c sub n, where a sub n is going to 1 and c sub n is going to infinity. Okay, so this leads to what we call an indetermination. Okay, indetermination, or indeterminate form of the type 1 to the infinity. Okay, this is the kind of limit. Well, every time you find something like this, the limit is going to be something like e to the c, where c is the limit when n goes to infinity of a sub n minus 1 times c sub n. Okay? So this is just the same that we're saying here, but with the basis of the expression is different. Okay? So remember, you have 1 plus b sub n when b sub n is going to 0 and c sub n is going to infinity. You have this e to the limit of this. And if you have a sub n is going to 1 and c sub n is going to infinity, then you have e to the c, where c is given by this. Okay, these two things are very, how to say, it's equivalent. Okay, so let's see, apply this to one other example. Let's see, the limit when n goes to infinity of, and then we have 3n squared plus 1, and then we have 3n plus 2, n minus 3, and then to the 2n plus 1. Okay, so if you compute the limit here, as we have said, so this is 3n squared minus 9n plus 2n minus 6. Okay, so you have 3n squared above, 3n squared below. Okay, we remember you need to always focus on the highest power of the numerator and denominator. So the quotient here is 1. Okay, so this is going to be 1 to the infinity. Okay, so this is an indetermination, just like the type we have seen. Okay, so the limit actually is going to be e to the c, and c is the limit when n goes to infinity of 3n squared plus 1 over 3n squared minus 7n minus 6 minus 1 to the, not 2, times 2n plus 1. Okay, so this is the whole limit. Okay, so this is just the same as the previous exercise that we have seen. Now let's operate with this. So we have, this is the limit when n goes to infinity, and then we have 3n squared plus 1 minus 3n squared plus 7n plus 6 over 3n squared minus 7n minus 6 times 2n plus 1. Okay, 3n squared and 3n squared cancel each other out, so then you have 7n plus 7, so 7 times n plus 1 times 2n plus 1 over 3n squared minus 7n minus 6. And just like before, we have two denominators, sorry, the polynomials in the numerator and the denominator, and the limit of this is going to be the highest degree of this. So this is something n squared, right? If you expand this, this is going to be 2n squared plus something that's in n and 0 order times c. So this is 14n squared plus something that's smaller, and this is 3 times n squared plus something that's smaller. So this is 14 over 3. That's the limit. So the limit of this is e to the 14 over 3. Okay? So that's the end of this